previous video, we had discussed about the compounds which have a double bond, or rather a multiple bond, a functional group, as well as a side chain. In this video, we are going to be talking about compounds which have two or more than two functional groups. So when we were studying about the basic idea behind the basic, characteristics or the basic introduction of the IUPAC nomenclature, we learned that it consists of a word root, a prefix, and a suffix. Now, the word root gave us the information on the number of carbon atoms. The prefix was either going to be the side chain, or I'll tell you 1 minute. Next was the suffix, which gave us the information about the presence of double or triple bonds and the presence of a principal functional group. Whereas the other group, which is apart from the principal functional group, that is the ones which are not included over here, are represented at the prefix. So in a compound, when it has, let's assume it has two functional groups, one of them would be the principal functional group, and that will be denoted as the suffix, whereas the other ones will be denoted by a prefix. We had learned about the various functional groups along with their suffixes in one of the previous videos. I think it was after we learned about the classification. It's better that you know or have an idea as to what the suffix is for each of the principal functional group. Now, when we have a functional group, when we have two functional groups, there has to be a way by which we can order them or give them priority, which means, suppose you have a compound which has both an acid as well as an alcohol. The principal functional group would be the COOH group, whereas the alcoholic group would be the secondary functional group. So here, this is the order by which you have it in the decreasing order of priority, and this is the way we decide on which would be the functional group. You have it starts from carboxylic acid, then you have sulfonic acids, acid anhydrides. Acid anhydrides are basically, they have COO instead of H, they have another CO group attached to it. They're acid anhydrides. Then you have an ester, then you have acid halides, acid amides, cyanides or nitriles rather, COH or aldehydes, ketones, alcohols, amines and ethers. So the remaining groups which are not included here, like halo, nitroso, nitro, alkoxy, alkyl, all of them are treated as substituents. This means that these will be denoted as a prefix. So suppose you have a chlorine in a molecule. Let's take, for example, we have Cl, CH2, CH2, CH3. Irrespective of the fact that it does not have any other functional group, this is called as chloropropane or propyl chloride or chloropropane. So these groups are generally treated as the substituents, and they will be in the form of prefixes. So halo or chloro, fluoro, bromo, iodo for halogen. Then you have nitroso, NO group, nitro, NO2, alkoxy, OR, alkyl. So over here I have written down the various functional groups along with their prefixes. For example, it starts with COH having carboxy, and I think it's in the order of priority. So this gives us the information about the fact that, first of all, when one of the group is considered to be the principal functional group, when it's a secondary functional group, then the prefixes over here are used. So here I have 5 examples of compounds that need to be named. So let's start. The first one over here. Here, if you notice, there are 2 functional groups. So this is one and this is the second one. So before we decide what, like write down the names and stuff, we need to figure out which of them is the principal functional group. So over here, COOH, there is an acid comes before a ketone. So the acid becomes the principal functional group. So I'm going to write P over here, and this becomes the secondary functional group. And the numbering is supposed to be in such a way that the principal functional group is going to get the least number or lesser number compared to that of the secondary. So it gets more priority basically. So COOH is an acid, and since it's the principal functional group, it's going to be oic acid. And CO is a ketone, so it's a oxo. This will be oxo, will be the prefix. Now the number of carbon atoms are 1, 2, 3, 4 and 5. So it's a pentane, or pentan, because it's an oic acid. So the name of the compound, first we need to put in the prefix, but the number is going to, the number for the prefix is, it's basically at the 4th carbon. So 4-oxo. Next will be the word root, penten. And because this has it's a vowel, the E gets removed. And so penten oic acid. So here, the first one, first we saw that there are two functional groups which are present. There is the acid and the ketone. Acid is the principal functional group because it has more priority, whereas the ketone is the secondary functional group, and so it will be written as a prefix, while the acid is going to be the suffix, and so the name of the compound is 4-oxopentanoic acid. Next, in this compound, you have two functional groups again. This is a ketone and this is an alcohol. According to this order, the ketone comes before the alcohol. So the ketone's going to be the suffix or the principal functional group. So it will be on, whereas the alcohol's prefix is hydroxy. So, here, irrespective of whichever side you number it from, the CO group is going to be 2. So irrespective of what numbering we do from right or left to left or right, CO is going to be 2. So to ensure, this means that we can number it in such a way that at least the hydroxy group also stays gets number 2. So hydroxide is at the position 1, ketone is at position 2, and it's a 3 carbon chain. So propane. Now let's order this. So first is going to be our prefix, that is 1-hydroxy propan. It's at the second position, 2-on. So here we had hydroxy as well as ketone, and since alcohol is after ketone in the order, that makes alcohol the secondary functional group or the substituent, whereas the ketone is the principal functional group. Next, in the third example, here we have 3 functional groups. So we have alcohol, we have a fluorine, we have an acid, and from there it's quite obvious that the acid is going to be the primary or rather the principal functional group. So it's going to be present as oic acid. Okay, next, alcohol will be in the form of hydroxy. So since our COOH is obviously terminal, so it's going to be at the end of the chain, right? So we'll be numbering it from the right to left. So we have fluorine at the second position. So fluoro is at the second, and you have hydroxy group or the alcohol group at the fourth position. So hydroxy at the fourth position, and since it's 4 carbon atoms long, it's butane. So we need to order the fluoro and hydroxy in the alphabetical order. So the name of this would be, since F comes before H, the name of this particular compound is 2-fluoro 4-hydroxy butanoic acid. So 2-fluoro 4-hydroxy butanoic acid is the name of this compound. We had 3 functional groups, OH, F and COOH. COH is a principal functional group. OH as a prefix is hydroxy. F is going to be a prefix, and it's fluoro. Next, in this compound you have 2 functional groups as well as a methyl group, which is a side chain. So the functional group, as we know, COOH is going to be the principal functional group, and it's going to be oic acid. So here we'll number this. So after numbering, we know that the ketone group is at the second position, okay, and the methyl group is at the third position, and M comes before. So this is a methyl, this is an oxo, and M comes before oxo, so the name will be 3-methyl 2-oxo methane, ethane, propane, butane, butanoic acid. So 4 carbon chains long, so the word root will be butane, and it's an acid. Its principal functional group is the acid, so oic acid. CO is a ketone, so oxo, and its position is at the second position, and methyl is the side chain which is present in this group, in this compound, so it's at the third position. Now this is the last compound. Here you have 2 functional groups, again similar to this compound. Here, however, we have an extra methyl substituent. So, and this is 4 carbon atoms long. So here we'll be numbering it in such a way that this group gets the least number. So if we do from left to right, this will be the third position, whereas from right to left it's going to be the second position. So at the second position, we have a ketone group, and since it's a principal functional group, it will be denoted as on. And at the third position, we have 2 things. One is an hydroxy, which is an alcohol, and we have a methyl group. And it is 4 carbon atoms long, so it's butane. So combining all of this, the first one, alphabetically speaking, H is before M, so 3-hydroxy, 3-methyl, butane, butane, 2 on, because the ketone is at the second position. So with that, we complete compounds which have 2 or more functional groups in them. We have an order by which we decide on which is going to be the principal functional group. The other one is treated as a substituent or a secondary functional group, which is given in the form of a prefix. We learned how to give the we learned about what prefixes are, what suffixes are, and what the word root is in the previous video, or rather the beginning of learning about IUPAC nomenclature. All I did was order it, and for you, if you find it easy, it's always better to practice nomenclature. Have the textbook open, have all these open in front of you, and then if you try and write down the names and the more you practice, the more you'll be able to write it on your own without the textbook in the first place. So with that, we complete the compounds containing two or more functional groups. In the next video, we will be talking about alicyclic chains.